Today we're going to look at solving quadratic equations by graphing. Here's the new vocabulary that is going to be introduced in this section, so take a second and write these words down. We have quadratic equation, standard form, root, and zero. So the standard form of a quadratic equation is when your quadratic equation is set equal to 0. So we have ax squared plus bx plus c equals 0. That's the standard form, is when it's set equal to 0. So in class I've been making a really big deal about solutions. What does the solution mean? When it says solve for, or what is the solution of this function? I've been making a big deal about what that means in certain contexts because it's very important. If you don't know what the question is asking, then how can you actually answer the question, right? So we're looking at solutions of quadratic equations. What does that even mean? What are we looking for when we're looking for the solution to a quadratic equation? So they're called roots of the equation. That's another term for solutions, is roots. And one way to find these roots is to find the zeros of the quadratic equation. And here's a nice visual way to represent what this means. So take a second, pause the video to write down this entire thing because it's super important. We have solutions of a quadratic equation. In words, a quadratic equation can have one real solution, two real solutions, or no real solutions. And models, they have a couple of graphs, or a few graphs drawn here. So if we have one real solution, it's where our parabola touches the x-axis in only one spot. Do you notice that? And then this parabola crosses the x-axis in two spots, so therefore we have two real solutions. In this parabola, the parabola doesn't even cross the x-axis, so we have no real solutions. So we have three different types of solutions that we can categorize, but if you notice, the solution is always where the parabola crosses or touches the x-axis. So I went ahead and labeled these points. If you notice, I labeled this point M, so that's just a number. I don't know the exact number here, but I'm going to call this number M. And this is going to be N, and this is going to be P, because I want to show you some notation that we're going to be using when we're describing what our solution is to our quadratic equations. So if I'm looking at the first parabola, this one right here on the left, and I want to say that the solution is M. Okay, we're going to use what's called set builder notation. And if you noticed in the last video, you use set notation also with domain and range, which you may have seen before, but this is going to look a little bit different. So than domain and range. So for this, I have that for my first graph, this one right here, my solution is an x such that, that line straight down is such that, and I can go ahead and tell you that with a little arrow, such that x equals m. There's only one solution, so we only have m there, and then end curly brackets. So this right here is how you would describe your solution. This is how you would write it in set builder notation. So we have the set, which is this curly bracket, of x, any x value, such that x equals m, end curly bracket. Okay? Let's do that for the second one as well. So if this is our number 2, okay, then we have the set, that's a ugly curly bracket, but it works, of an x, or any x's, such that x equals n, comma, p. It can be n and p. And for the last parabola, it does have solutions, but they're imaginary, and we're going to go over that a little bit later. So for now, if you get something that looks like this, where the parabola does not cross the x-axis at all, then you're just going to write that there are no real solutions until I teach you about imaginary complex solutions. There are many ways that we can find solutions to quadratic equations. So we can find them by looking at a graph, which is what we're going to do today. We can find them from a table. We can find them from looking at a graph on a calculator, which is what we're going to do in class tomorrow. And also by factoring, or an algebraic way. There's just like when we were looking at solutions of systems of equations and systems of inequalities, we had a lot of different ways that we could go about finding those solutions. This is the same idea. We have quadratic equations and we're looking to find their solutions, and we have a multitude of ways that we can do that. So let's take a look at an example. F of x equals x squared minus 6x plus 9. In a previous video, we learned how to graph them, so to save time in the video, I have it graphed for you already. So we're just going to be looking at this graph to find what the zeros are, or find what the solutions are. So if we look, and we're looking for the vertex, right? Because the vertex is what's crossing or touching the x-axis. So in this, we have one real solution. And if we look at where it is, our solution is, so if this is x equals 0, we got 1, 2, 3, where x equals 3, right? So if we write our solution in our set notation, we have a set such that x equals 3. And that's our solution. There's only one zero, one real solution, and it's 3. Let's take a look at another example. We have x squared plus 4x equals 0. And again, it is already graphed for you. And we're just going to look and find where our parabola crosses our x-axis. So if we look, we have that our parabola is crossing our x-axis at 0 and at -4. So in this one, we have two real solutions. So you have two real solutions. And we have our set notation, where our answers are x such that x equals -4 and 0. Pretty easy, yeah? So in class tomorrow, we're going to be looking at how to find these when we're just given the quadratic equation, how to find them on a calculator. I want to work with you guys on how to become really fluent with the calculator so that it's helpful to you on the ACT instead of you having to do everything by hand. So be ready, be prepared tomorrow to be working with a calculator and doing a lab.